The next one is a very straight question asked in GATE 2006. The question is the Dirac delta function del of t is defined as. You have four options. Um, option option A says del of t equal to 1 at t equal to 0 and 0 otherwise. So this thing del of t is a continuous time function, right? Del of t is continuous time. Okay, del of t is continuous time delta function because we have a del of n which is discrete time also. So this one is continuous time. So plotting the option A, we may get something like this. So at t equal to 0, the amplitude is 1 and 0 at all other places, all the values of t. Is this correct? No, this is not the expression for del of t. Okay. So the option B, now we can look, so we have rolled out option A. Now option B, let us check option B. So option B says that del of t equal to infinity at t equal to 0. So at 0, this is infinity at t equal to 0 and 0 at all other places. Is it correct? It is partially correct, but let us see the other options also because the option should be the most appropriate option should be the answer. Okay. Now let us see option C. Let's see option C. Del of t equal to 1 for t equal to 0, 0 otherwise. So it looks like something like this. And they have said another condition, integral or the area under the graph is equal to 1. That is correct, but this is wrong. The amplitude is not 1. Okay, so we can rule out option C also. Now let us look at option D. Option D says that del of t is infinity at t equal to 0. So like this, okay, del of t is infinity at t equal to 0, and this is the most important part, and integral over del of t dt equal to 1. That means strength or area or under this impulse signal is 1. So that is the perfect definition. So option B is partially correct, but we have to add this condition also. Okay. So option D is the correct answer, the most perfect answer. But here I would like to tell something out of the board because this answer is also not perfect. In the given options it is perfect, but this definition has some kind of problem because what I'm saying is that they have defined del of t equal to infinity for t equal to 0 and 0 for t not equal to 0 or otherwise, and integral over minus infinity del of t dt is equal to 1. Area under the graph is 1. But this is a definition, right? They have clearly mentioned the left is defined as. And what is this? This is infinity. Is that defined? Can you define a definite value for infinity? No, no is the answer. Then my question is, how can you include something that is not defined in something you call a definition? That's absurd, right? So in standard textbooks like Simon Higgins and all, you can see the definition of impulse signal is del of t is equal to 0 for t not equal to 0. Okay, del of t equal to 0 for t not equal to 0, and integral minus infinity infinity del of t dt equal to 1. This is the perfect definition because we can always say del of t equal to 0 for t not equal to 0. For all t not equal to 0, del of t equal to 0, and at t equal to 0, we don't know what it is, cannot define it. So we can always say integral del of t dt minus infinity del of t dt equal to 1. This is the perfect definition. In standard textbooks we can see this as the perfect definition. Okay, so anyway, in the given options, option D will be the perfect, more appropriate option. Okay.